All right, so today let's take a look at the curriculum. We're going to be talking about HTTP. And HTTP stands for Hypertext Transfer Protocol. It's the way that the web transmits information back and forth. We're currently in week 5, right in the middle of the week. We're going to talk about the theory of HTTP. If I have time, we're going to talk about fetch with JavaScript. If not, Tom will cover that with you. And we're going to solve just one challenge today. It's a fairly big challenge. It's going to take 3 days to solve. There's going to be HTTP server 1, 2, and 3, similar to old projects that we were building on for a few days. So we're going to build the entire server. The good part about Google Chrome and Safari and Firefox is that it has a server built in. Like everything is nicely packaged up for you, so you don't have to really worry about anything. It makes a request and gets back a response. But your job is to create your own version. HTTP server 2 includes the answers to HTTP server 1. 3 includes the answers to 2 in the case that you ever get really, really stuck. This is fairly advanced, but we did try to write it in such a way where you can, you'll be able to, more or less look ahead and see all the answers that you need to. So what we're going to do first is we're going to talk about the theory of HTTP and why it works and how the web works in general. So HTTP, the web's protocol. HTTP. Yeah, I'm recording it. HTTP stands for Hypertext Transfer Protocol, and it's just a protocol to transfer hypertext. It's literally what it says, Hypertext Transfer Protocol. So the way that we used to send information back and forth over the intranet, not internet, but the intranet, like whenever universities were trying to share large bits of information within a closed network, was using hypertext. This protocol started off in 1991, goes back as early as 1930, I don't know, it's kind of fun. So hypertext, hypertext was the old way of transferring information back and forth within an intranet. And the modern equivalent of today is HTML. It's supported much more than just linking one page to another. But HTML is not just the only thing that's sent over the web. We send things like images, entire CSS files, JavaScript, API responses. We send images, movies, we send everything using this particular thing called the Hypertext Transfer Protocol. So think about your day-to-day interactions with people, right? There is a request and there is a response. That's pretty much how the entire day goes. I can walk up to somebody, and the way that I initiate a conversation is me as the client, I am the person that's making the request to have a conversation, and the server, which is the person receiving that request, is going to acknowledge that and then come back to me. So if I am a person who sticks out my hand and says, "Good morning, how are you?" "Good, how are you?" "Good." So I'm the client in this particular situation, right? I'm making a request to Jordan, and I stick out my hand. I say, "Good morning, how are you?" And then he is the server. He's the person receiving that request and basically saying, okay, I'm seeing that this person is smiling, putting a hand out, which is an indication of friendliness, and I'm going to respond in a particular way. There's a lot of unspoken communication when we have a peer-to-peer conversation. There's things that our brain picks up on, like, okay, is this person coming at me very, very fast? Are their fists clenched? Do they look angry? These are things that are happening on a microsecond basis that your brain is automatically picking up on. His response when I do this is very different than if I were to come in real angry with this like this, right? There's a very different response that happens in that split second. And that describes kind of like the conversation between two people. There's a lot of unspoken things. When we're talking about HTTP conversations, the person making the request to the server, like when you go into Google Chrome and type in google.com or amazon.com, you are the client at that particular point. You're making the request to the server. The server will receive your request and figure out what kind of response do I need. Similarly, I say hello to Jordan. I'm the client. I make the request. He's the server. He's making the response. Unlike human beings, however, computers don't pick up on things like body language or tone or facial expressions or something like that. They have to be extremely explicit with this is the type of the request that's coming through, and this is the type of response that's coming back in order for it to understand things. So, like it says, the client sends an HTTP request, the server sends the HTTP response, and they're just written as plain text. Let's take a look at the request here on the left-hand side. This is what a request looks like. It starts off with this particular line. It's built up of the method, the URI, and the HTTP protocol version. Currently, we're on 1.1. We're going to be on 1.1 until the HTTP web lords tell us that we're going to be on a different version. So method, URI, and then protocol version. These are some of the methods that the HTTP verbs, like the verbiage that you need to know. Get, post, put, and delete. Get is pretty simple. So if I'm going to make a get request to /bios.html, I'm saying I want to get something from you. So it's like, hey Jordan, can I have $1 million? No. Okay. Well, that's still a get request, right? I'm requesting something from Jordan. That's example of a get request. Whenever you go on your machine and you type in apple.com, amazon.com, chase.com, you're making a get request at that particular point, saying I need to receive some information from you. I need to get stuff. That's retrieving a resource. Okay, Jordan, here's a cup of water.
Thank you.
Okay, thanks. That's a post request. I'm sending something over. So when I type in chase.com and I press enter, that's a get request. I'm asking for information. When I put in my login information, like my username and my password, and I press log in, I'm posting that stuff over. I'm sending stuff over. So that's like me handing this cup of water over to Jordan. So real quick, which method is the one to send stuff over? Post. Cool. The third one you need to know is a put request. The put request is basically like, I already have stuff on your website, but I need to make an update to it. I'm not sending anything. I'm technically sending. So technically all put requests are post requests, but not all post requests are put requests. Because I'm sending information over, but it's specifically in a way that I'm updating something that's already on there. So let's say that you get married and you decide to change your last name or your first name. You need to change some sort of information, but I already have like an account of that on your website. I'm going to send a put request saying, so it's like, here, Jordan, here's a cup of water. Okay, I'm going to add lemonade powder to that. Oh, okay, so it's like you already have that cup of water, and I'm going to update something there. So get, again, is to retrieve something. Post, I'm sending you something. Put, I'm sending you something, but it's going to update a record. And finally, we have delete, self-explanatory. I need you to delete something. John?
So is the server deciding whether or not the post is the put?
The client is making, so again, we're talking about the request at the current moment. And remember, clients make the request. Clients, yep.
But what if the client tries to put something that doesn't exist?
That's a good question. Hold on to that one. But the short answer to it is that if you're trying to post or put something that doesn't exist, they'll give you a 404. Yeah. So we talked about the verb. It's going to be get, post, put, and delete. Get makes sense. Delete makes sense. Post is for sending information. Put is for updating information. Those are the things you must memorize. The second thing that comes is the URI, which is the Uniform Resource Identifier. What on earth is that? So when I make this request, this includes a URI, which is /bio.html. A URN is the host name, which is like amazon.com, plus the URI, which is this thing over here. A full URL includes what protocol am I using? HTTP, HTTPS, that's where the HTTP comes from. Using the HTTP protocol, reach out to example.com and specifically I'm asking for bio.html. That's the thought process behind this. So a URL includes the HTTP protocol, which is HTTP. It includes the host over here, which is where the website, like the domain of the website, plus the URI. You don't really need to know this, it's just for your informational purposes. What is the difference between HTTP and HTTPS? S is for secure. So if you ever go to a website and I go to like, I don't know, Wells Fargo, what you'll notice is that whenever I click on it, there's an HTTPS. This is the web's way of saying like everything that you send over is encrypted. You'll also notice that on the top left corner, there is a little lock button. This will make sure that all the data that you're sending back and forth is encrypted. If you were to go to a website that doesn't have HTTPS at the very end, what that is basically saying is like whenever you log in or log out and you enter your password, it's sending it in plain text. It's not encrypting it in any way. I can actually read the network traffic, like all the requests that came through that day, and find your username and password pretty quick. I used to have an example of this, but unfortunately that website was shut down. So again, like I mentioned a little bit earlier, when we make requests human being to human being, like I can tell based off of things like body language, facial expressions, like speed of coming at me kind of thing, what kind of request is being made, because those are things that the brain immediately picks up on. The computers need everything to be extraordinarily specific, which is why all requests are built in this way. I start up with a request line. I want to get some information from this URI using this HTTP protocol version. I'm also passing in some optional things, some headers in. This is the host, so this is where the website lives. So it's like amazon.com/baby items. /baby items is the URI. The host is amazon.com. And then we have also the user agent. This is basically what type of machine is making this request. And why do you think that having this is important?
Because every browser has a different implementation of the standard that we call here.
Yes. Yeah. So Ethan was saying that every single browser has different implementations of how they interpret HTML. That's true. Another reason why user agent is super important is because Google Chrome 5234 might be for desktop. But if you go to a mobile app and you're making a request from iOS's version of Chrome, the response is going to come back a little bit different. Think about it like this. When you talk to an adult, there's a particular way that you have a conversation, right? I'm just going to talk to you like this. If you're going to talk to an 18-month-year-old, like a small baby, your voice goes a little bit higher, you're a little bit more playful, you got to be a little bit more animated in order to get their interest, right? So that is the way that we're basically saying, like, this is how I'm going to, like, there's a way that I talk to an adult and a child, and this similarly, there's a way that HTML is returned to us using the like a website Chrome and the mobile version. One of them is going to be smaller, one of them is going to be bigger. We've all been to those websites, the really old government ones on your phone, where it's like it's not mobile friendly, and you have to like scroll like this and then move all the way to the right in order to log in. That's a non-mobile friendly website. But you've also been to the ones like Google, where it's like it automatically seems to shrink. A good example of that is if I were to go to apple.com. What you'll notice right now is that this is what's called a responsive website. We'll talk more about this when we get to Bootstrap, but this is a responsive website. It looks like this in full desktop mode, but as I shrink it, it'll automatically restructure itself, and now we're in mobile mode. It will reshrink so that when I click on this, it still has everything, and as I expand it, it'll turn into tablet view, and then ultimately into full desktop view.
So besides the user agent in the browser, it also has some information about the screen resolution and the window size.
I'm going to say, for the short answer, yes.
Okay.
Short answer is yes. Long answer is we'll get to that in Bootstrap.
Okay.
Yeah. This is an example of a GET request. I'm getting information. It's pretty simple. This is where I want to go. This is the type of machine that's requesting. When I send over stuff, that's a little bit different. So I changed the HTTP verb. Post is what? What am I doing with post? Nope. Post. Requesting is get. I'm going to go with. You're sending. Yes. Oh, thank you. So I'm sending information to /search using HTTP protocol 1.1. Same thing as before. I want to go to this particular host. This particular user agent is making the request. But I also need to say, like, this is what I'm sending over. And it's going to be in encoded form, and this is the actual body of the thing that's being sent over. Kind of like a manifesto. when I send over something and I need to declare it at customs or something, I will say like, this is the type of stuff that's inside of this package. This is the type of request, the content type of request that's being sent over. Yeah.
This might be a dumb question, but where is this happening? Like,
This is actually all happening behind the scenes of your browser.
Okay.
Yeah, so you're having like a nice way of viewing it. So like this, all these conversations are happening behind the browser. And you don't ever really see it, but it is happening in the background, as we'll see in just a second. Sometimes, so you can, so when let's say I go to target.com. My target, what kind of request did I just make? I typed in target.com and I hit enter. It's a GET request because I'm saying, hey, get me this information. All right, so let's say I'm looking for lawn furniture. I'm gonna click on this. Was it a GET?
There's
That's a post. Because I
I
sent over information, right?
They post all they get of the generated page from based on the
It may be a GET on their end, but technically on my end it's still post. Yeah. Their response is HTML, and that's what displays over here. So if I go over here and I right click and I say inspect, what you'll notice is that we have all of these things called Chrome Dev Tools. We've seen this before. Yeah. But if you click on network, where is it? Sorry, there it is. And I refresh the page, what you'll notice is that even though I made one GET request, which was I refreshed the page, remember, I just press enter over here, underneath the hood, Target is making 161 other requests to get everything on the page. Now, if you look at this page, you're like, okay, there's a lot of stuff that they need to do. They need to, they need to get every single image from somewhere. That's a bunch of GET requests in the background to get a bunch of images. They need to get all the titles of all those, of that information as well. They need to get this header bar up here, and if you jump all the way down to the bottom, they need to get this footer as well. They're making, bless you. They're making, oh, they still make requests. For every single one request that you make, Target needs to make other requests to get information so that it returns in this nice, beautiful format for you. 206 of them, in fact, just to make this one individual page. You don't need to worry about that because your browser's taking care of it and Target's taking care of it, but just know that that is what's happening underneath the hood.
Visually, we'll need to worry about it if we're building Fireman's website.
Correct. Yeah. What you'll also notice is that you can make a post request like I did earlier. I looked for lawn furniture. Cool lawn furniture. And I made a post request right there because I filled out this form and I pressed enter, so I sent over information to Target. But what you'll notice also at the very top is if you don't want to make a subsequent further, if you don't want to make future requests and you just want to come back to this page, you can just copy and paste it up here. And if I look up here, it looks like there is what's called a query search. That's what we're talking about with query parameters. If you see a question mark inside of your URL, what follows is basically the query search. So you'll notice that it's target.com/s, probably stands for /search, question mark, and then here's a bunch of the things that you need that is relevant to what you typed in. Search term equals cool plus lawn plus furniture. So if I were to get this, remember this first item here, Fortuna 8-piece outdoor patio set. If I open it incognito, I copy and paste it. Now this is a GET request. This is not a post request anymore, and I press enter. I get the exact same thing as I got before, again with that Fortuna 8-piece outdoor patio furniture. Different color, but who cares? That's the example of what's called a query parameter. I've also really always wanted to have lawn furniture inside my house. I think it looks really nice, but then somebody else said, my mom has that, it doesn't look good, so. So what you'll see over here is you can post stuff over, and then sometimes they will return to you the GET at the very, very top. So you can just copy and paste that link, send it to somebody else, and you'll always get the same search results. That's what we've got over here. We've got get/search and then a question mark. So we know that everything that follows is going to be some sort of a query. Query equals air percentage 20, Jordans, and red equals color. So this is probably like I went to, you know, shoes.com and I looked for red Jordans, red Air Jordans. What is this percentage 20 here? Anybody have any idea? It's a space. This is the Unicode for the space, because you can't pass in a space inside of a URL, right? Like you've never seen a URL with a space in it. So they need characters to represent spaces. In some places, it's just a plus sign, like in Target. And for other places, it might be percentage 20, which is the, oh, this is the UTF code for this. So these are other examples of request headers that may or may not be passed in. So host equals example.com. This is like where I'm making the request to. What language am I willing to accept? Again, if I'm here in the US, I'm going to make a request to somebody and I speak in English, there's an implicit understanding that the response that I want in return is also in English. That doesn't necessarily apply to my house, but in my mom's house, but you get the idea. There's like unspoken rules, but when we make requests via the computer, it has to be absolutely specific. If I went to google.com and it returned me the Spanish version of google.com, I'm not really sure what I'm supposed to be looking at. So I'm always implicitly sending this language as English.
That's based on your browser setting, right?
Yes, in the current country that you're in.
IP-based.
What kind of machine is making a request? This is important for both mobile friendly and desktop, but it's also important for the particular company. So I used to work at a company that did loan servicing for subprime loans. Not proud of it, but I needed to make a living. Yeah. And they said, one person made a request saying, I can't see anything on my machine. And I said, okay, let me take a look at the request that came in from your IP. And I saw that the user agent was Internet Explorer like 3. By gathering a bunch of metrics, like I know that Google Chrome takes up 50% of the requests coming in, and Firefox takes 40%, and Internet Explorer takes up 1%. You can kind of make data-driven decisions on whether or not I want to actually update Google Chrome, Firefox, or Internet Explorer. I don't care if 1% of my users can't see my stuff. I care if 50% of the users can't see my stuff. So I will prioritize based off of that. And then finally, things like accept, what am I willing to get back from the server? So we talked about half of it, which is the HTTP request. And now we're going to talk about the HTTP response that comes back. It's built up of the status line, the headers, a blank line, and then an optional body. So let's talk about the status line first. We've got a code, a phrase, in the HTTP version. Again, it's always going to be 1.1 for our purposes here. These numbers that come back, there are a ton of status codes. There are hundreds of status codes. But the only thing you need to worry about is the first number on the left. 200, 300, 400, or 500. And the way that I like to explain it is that, let's say that you go out to a bar or a nightclub or some place where you want to meet somebody that you're interested in. You see this person across the way, and wow, it's like that's the most attractive person I've ever seen. So you walk up and you ask, hello, my name is John, and I find you very attractive. Can I buy you a drink? I made a request. I'm the server at that point, and then the person that I made the request to can respond in a number of ways. There's only four ways that they can respond. 200 is, yes, you can buy me a drink. I like double whiskey. I was like, okay, fine, I'll get you a double whiskey. They can also say, no, I'm not interested whatsoever. So it's yes, no. Let me introduce you to my friend. I acknowledge that you made a request to me, but I'm not interested, so I'm going to redirect you somewhere else. So when you go to google.com, it automatically redirects you. That's a 300 level status code. And then 500 is an internal server error. It's a no, but it's not you, it's me. I had bad sushi, it's not a good time for me right now, like a whole bunch of things. So again, I make a request to somebody I find attractive. 200 is yes. 300 is let me introduce you to my friend, that's a redirect. 400 is no. Could be a variety of reasons why it's no, but it's just no. And then 500 is it's internal server error. It's not you, it's me. Food poisoning, bad timing, out of town, whatever, internal server error. So let's jump back real quick. What is a 500 level status code, Ethan?
Internal server.
Internal server error. So this generally happens around, if you've been exploring the web at like 2 to 4 o'clock in the morning, and there's a bunch of 500s that come up, or it's not you, it's us, internal server error. That's when they're doing their updates. So that's the least amount of traffic they're going to update at that time. They don't know. They're not ready to respond to you at that time. Let's say 300 sites. Redirect. I'm gonna let me introduce you to my friend. Have you met Jordan here? 200.
Okay.
Okay, and then 400. No. There's a little thing.
503 is my favorite.
There's HTTP status code dogs. So there's a lot of 200 level status codes, but the most important thing is the 2 that comes in the front. That means it's okay. So we've got this happy dog. He says it's okay. We've got a 300. 300 level status code is like a redirect. They don't know what's going to happen, so there's multiple choices. There's a permanent redirect. You know, if you go to google.com, it's going to 308 https www.google.com because it automatically will permanently redirect you there. There's a 400. You're unauthorized to 401. You're unauthorized to come inside of here. So you got this big dog guarding the little dog, can't come in here. And then 500 is a bad gateway, internal server error. Maybe this dog is not feeling too well today, so it's going to sleep. Bad gateway. Obviously, this dog can't fit inside of here. It's just kind of fun. Come over here to take a look at all these different status codes. There's also one called, is it 418 I am a teapot? I don't know the exact history behind this, but I'm pretty sure it's just one of those like Easter egg things that when they were first creating it, they threw it in here. Oh, I think it's because back in the 90s when they first created this, like everything was about Java and like coffee-based things. So when they made fun of the tea drinkers by saying I'm a teapot and threw the 400 on there, I think it's something like that. So we know the status codes, 2, 3, 4, and 500. These are some of the response headers that are going to come back. Remember, when I send stuff over, I'm sending explicitly a whole bunch of crap. When I receive stuff back, I'm explicitly getting a whole bunch of crap back as well. So things like, this is the type of stuff that I'm sending you back from the server. HTML, maybe it's CSS, maybe it's something else. The length in bytes, do I need to set a cookie? Like so that like when I log in, maybe they send back a cookie saying like, oh, this is a token that you're going to store on your end that says you're good to continue logging in for 2 weeks. And then the current date of when the response was set. Yep.
So I think I know what a cookie is, but could you just explain briefly what exactly?
Yeah, that's actually the next slide.
Oh, okay.
Yeah. So the question was, what is a cookie? But I'll get into that next slide. We already went over this. When you go to target.com, you have to make a whole bunch of requests. One of them is just the HTML, just the bare bones of it. Remember, the HTML is like the frame of your house. Then the CSS, like how is it styled? That's like the coat of paint and the touches that you have. JavaScript, like if I go to twitter.com and I keep scrolling all the way down to the bottom, it's going to reload stuff every single time. You know, that's like all the JavaScript files that you need underneath the hood. Images, we saw it on target.com. There was 206 HTTP conversations just to load one particular page. So it's more than just one thing happening underneath the hood. Jumping into that let's see. Let's go back to HTML, CSS, and JavaScript. HTML, again, is the kind of like the bones of the house. Like what does the frame of the house look like? CSS is the styling of the house, and JavaScript is the behavior of the house. So in real life terms, my apartment was flooded recently. It's a 1-bed, 1-bath apartment somewhere in Chicago. Okay, so I know what the bones of the house look like because you see the new high rises being put up, so you see like the frame of things happen. Then the CSS, maybe it's like now that I have to repair it, what do I want my house to look like? So my floors are all crapped out because there was a flood from a different unit upstairs. So it's like maybe I need to change the the flooring a little bit. So I'll choose maybe gray floors instead of like laminate floors. Seems pretty cool. It's like the HGTV look right now. And so maybe I want to add some behavior. That's the JavaScript, the behavior of the website. So maybe I'll add like a smart home feature because since insurance is paying for it, why not? So again, HTML is the bones, CSS is how it looks, JavaScript is how it functions. John asked a question a little bit earlier about cookies. So one thing that you have to know is that every single HTTP conversation between you and a website is what's called stateless. So think of who has seen the cinematic masterpiece that is 50 First Dates? Okay, the worst movie ever, but I loved it when I was a kid because it was always on USA. The premise of the story is that Adam Sandler is in Hawaii and he finds this person that he's really attracted to named played by Drew Barrymore. Drew Barrymore has amnesia, so like always forgets him, and he has to like try to like woo her over 50 times, hence the term 50 first dates. So he has 50 first dates to try to get her to remember him. And by the end of the movie, like that would be a really sad movie, to be quite honest, if it was just like him trying for the rest of his life. But in the end, you know, they have a child, and how does the movie end? It goes like they're on a boat somewhere, and every single morning he has this like VHS recording tape. He puts it in, and then she remembers who he is because she's watching all of these things with her there, even though like she has amnesia prior to a certain point. The web is basically Drew Barrymore. Every single time that you talk to Drew Barrymore, she doesn't know who you are. So it's a stateless system. This is good, really good for security because every single time you have to authenticate who you are. But stateless, like I can log into Google like Gmail one time, and I'm not asked for like my password again for like probably 2 or 3 weeks. So how is that really supposed to work? And that's where the idea of cookies comes into play. So the way that this works is I'll log into Gmail for the first time. I'll send a request to Google as a server. Google will receive that, and then they'll send back a response saying like, here's all your mail. Also, here's a cookie. Here's a little like way for us to keep track of you. So it's kind of like, that's like the VHS tape that Drew Barrymore and Adam Sandler had. They'll send over a cookie. That cookie is stored only on your machine so that in subsequent requests to Google, you send over that cookie as well. So it might be something like login cookie. And then basically your computer, your own machine will memorize that login cookie is like 3Z4HC, like some nonsensical string of letters and numbers and characters. And every request that you make in the future will also include that cookie saying like this cookie is attached to Jonathan, and that cookie is basically saying this person is logged in, so you don't need to re-ask them for their login information. We're going to learn more about how cookies work in today's thing, but for now, here's a summary. Again, same thing. The server, the thing that's receiving the request, sets cookies by sending them to the client as part of the response. Your client, your Google Chrome, your Firefox, your Safari stores those cookies, and the server doesn't store anything. Any further cookies that are part of that current domain are sent in subsequent requests. Let me show you an example of a cookie real quick. This is kind of disgusting, but I will show you. I go to network, nope, sources, performance, where is it? Where is my cookies? Let me how do I clear this?
I think you can do it from the log.
Sorry, give me one quick second. Where are you? Memory. There it is. Sorry, I couldn't find it. So your machine, your Chrome browser actually has cookies stored right over here. And these are some of the things that are stored in every single request. So there's a guest location. We're at 60603 at this particular lat and long. Every single request, they know exactly where you're coming from based off your internet service provider. So we get our Wi-Fi through WeWork. WeWork is hardwired to some sort of like RCN or Optimum Online or Xfinity or something like that. And then that registers as your guest location. So if it says like, hey, you're shopping here at Chicago State Street, that's how they can set that for you and makes subsequent requests a little bit easier. When I send over a future request, it always knows that I'm here at 60603 at this particular lat and long. Thus, it automatically merges me into Chicago State Street as my particular home store. What else? All of this is pretty user location, same thing as before. Access token, maybe that's an example. If I log in, maybe there's another token that's saved over here that's nonsensical, but when I send it over to them.
Information about what we looked at on
Yeah, let's say that, yeah, so this is typically for target, right?
Yes, this is specifically for, yep. Isn't that crazy?
Is that what you said is disgusting?
Yeah, it's a little disgusting. They have a lot of information about you. So.
You can disable cookies.
You could, but then your internet experience is complete garbage.
And I browse quite a bit all the time. Yeah.
All right. I'm gonna stop recording here. Yeah, let me stop recording here, and then we'll pause for questions.